Hello everyone. In this video, we'll be solving problem 3178. Find the child who has the ball after k seconds. The problem statement is we are given two positive integers n and k, where n is the number of children and k is the number of seconds. We need to identify at the kth second who will be holding the ball. In example number 1, where n is equal to 3 and k is equal to 5, the ball will first start moving from left to right until it is at the end, and if there are still any seconds remaining, it will then move towards the left. So we'll continue doing that until we run out of k or seconds, and whoever is holding the ball, which in this case is going to be the kid at position 1. I hope you were able to understand the problem statement. Now let's switch to whiteboard and discuss a couple of options, starting with a brute force approach, following up with an optimized one. When using brute force, we will run a while loop for k times, where k will be decremented after every run. We'll use the pointer to point at the kid who actually has the ball, and depending on which direction we are moving, we will either increment that pointer or decrement it. When we start the iteration, we'll set the value of the boolean to true because we are moving towards the right, so we need to increment our pointer. Once our pointer is pointing at the last element in the array, we'll flip the flag to false and then start decrementing the pointer. This loop will continue until k is not equal to 0. Once it is equal to 0, whatever the value the I is pointing at will be our output. With this solution, our time complexity is O of k, as we are running the iteration until the kth second, and the space complexity is O of 1, as we are not maintaining any additional collection, just using a couple of variables to maintain which position we are at and the direction that we want to move to. This is one way of solving the problem. Now let's discuss how we can optimize this solution to get a better time complexity. The first improvement that we need to do to our algorithm is to only run the iteration when we cannot complete the entire loop. That is, the ball should not reach back to the kid at position 0. The simplest way to do that is to apply the mod operation on n and k. And because n is not 0 indexed value, we need to first make sure it is 0 indexed. Because when we are starting the iteration, already the first kid at position 0 is holding the ball. So if we don't make n as 0 index, our calculations will be off. So we'll start off by decrementing n by 1. And now divide the two and figure out how many runs that we can make with the given n and k pair. 5 divided by 2, the output is 2, which means we can do 2 complete runs on the given inputs. After knowing the number of entire complete traversal we can do, there are two possibilities here. If the value is an even number, it means that we have completed the cycle and starting off again from the kid at position 0. And if the value is an odd number, it means that we have completed the traversal from left to right and the ball is with the kid on the very right position. Now we need to see if there are any remainders, and to do that we just simply have to do a mod operation. So after performing a mod operation on the same numbers like k and n, we'll get the value as 1, which means there's one more second where the ball can be passed over to the next kid. Now we need to decide in which direction the ball needs to be passed. Because the division output is an even number, it tells us that the ball needs to be passed from left to right. That is, we need to increment our pointer by the same number that we got as part of our mod operation. Hence our output is going to be 1. Let's replay the same example but use k as 7. With k is equal to 7, the total number of complete runs will be 3. As it is an odd number, it means that we have completed the iteration from left to right, and now whatever is the remaining, we need to start decrementing it from. Applying the mod operation on 7 by 2, the output will be 1, which means we need to decrement the pointer by that many in value. 2 minus 1 gives us the output of 1. With this solution, our time complexity is O of 1, as we are using these formulas to calculate the total number of complete iterations we can make and then what is the remainder. And the space complexity is also O of 1 as we are not creating any additional collection. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. This is my C# solution. As we discussed earlier, we need to make our n zero index. So I'm decrementing the value and then calculating the total number of rounds by dividing k by n. Following that, I'm calculating the remainder, which will tell me how many elements I need to still pass the ball to get that correct kit. If the value of rounds is even, it means we need to move towards the right hand side now. So I'm returning the remainder as is. If it is not an even number, that is it's an odd number, then I'm decrementing remainder from n and returning it. This code when submitted on LeetCode beats 100% of the submissions in terms of runtime and 36% in terms of memory. Thank you for watching this video. I hope you were able to understand this explanation. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.